We've been able to show very clearly that if you're not getting your scheduling right, you will constantly drop from your 80 odd kilos down to your 30 to 40 kilos of dry matter per hectare per day. So if you're irrigating and you feel really comfortable because you're seeing the irrigator go around and water go on, but the data that's coming back is telling you you're only growing at about 30 to 40 kilos, well then there's something drastically wrong with the whole system. And so if you can have a way in which that information can be fed back automatically and then the whole system can respond to that, then that's going to help to automate that process of getting watering right. Because of the topography, but also we've got an issue here with the amount of height. So from the bottom to the top of this is about 80 metres of difference. So having a variable rate pivot with a variable frequency drive means that we can actually water this in a more efficient way than if you just had a single pump and the same amount of application going on everywhere. We could, in this circumstance, grab information about biomass in an autonomous way that could be fed into a model along with all your weather data, your soil moisture data, and from there predict what we think might have to go into this pivot from a variable rate point of view. And so every day, theoretically, we can send a new map into that pivot externally without us having anything to do with it, and it can water according to that information. So that's the autonomous side of the whole process. So we've been testing that process here on this pivot, and then we've also set up a situation where we're comparing flat rate versus our standard variable rate versus the autonomous variable rate. And so we're just looking at that process, and we'll probably continue that process over another season or so and see what we can do in terms of the impact of our variable rate irrigation and the autonomous irrigation on pasture growth rates. Over the 3 years of this project, I've started off thinking, okay, it's going to be very complicated to get information for variable rate. As I've gone through the project, I've realised we can get the best bang out of our variable rate with the simple things first, and then perhaps look at the more complex later. Because the more complicated you are, the more you've got to rely on scientists and others to do the stuff for you, and they're not going to do it in the right time, and it becomes pretty difficult unless you've got somebody locally who can do it and supply that service.
So the variable rate map, is it dynamic? So is it changing? Are you updating that?
That's updated daily under the VeryWise system that we've been testing here. Yeah, so every day a new map, or as often as you want it to be, you can throw it into that, because it's all.
So what changes it? So what will change that map?
So the forecasted weather that's coming up, the temperature and soil moisture, the pasture growth rates, all of those things can be fed in. Now, I can't answer the questions around how that model's exactly working. You need to talk to Alison, who's the one who's developed that model, so the VeryWise model. So the brains behind all of this is the National Centre for Engineering and Ag. We're just the people who are testing it within our pasture environment. So they developed it in cotton and other industries, and it's been transferred across. So that's the beauty of the Rural R&D for Profit program. We're working with a whole heap of different industries, and we're benefiting from each other. And we're taking what's been developed in another industry and now applying it to something like pastures.